In these examples, the first thing we're going to do is split up the angles into the sum of two special triangle angles. So here I'm going to split this one up into 2 pi over 12 plus 3 pi over 12. This I can then reduce those fractions to be pi over 6 and pi over 4, both of which are special triangle angles. Both are located in the first quadrant, which means that their ratios are positive. And then I'm going to use the identity to split them up. So I've got cos pi over 6, cos pi over 4, and then I've got sine pi over 6, sine pi over 4. I'm going to continue simplifying using my special triangles that I wrote up here. Cos pi over 6 is root 3 over 2. Cos pi over 4 is 1 over root 2. Sine of pi over 6 is 1 over 2. And then sine of pi over 4 is also 1 over root 2. So here, I know that I've got a common denominator, so I can just subtract the terms in my numerator and simplify my answer. Now in the next one, I've got tan of 13 pi over 12. I can simplify this by breaking this up into two special triangle angles again. I've got 4 pi over 12 plus 9 pi over 12. 4 plus 9 gets me to 13. And now I've got this simplifies to pi over 3, and then 9 pi over 12 simplifies to 3 pi over 4. So now I can split these up according to my tan identity here. And this one I'm using tan of a plus b. So I can simplify this into tan of pi over 3 plus tan of 3 pi over 4 all over 1 minus tan pi over 3 times 3 pi over 4. Using my special triangles again, I've got tan of pi over 3, which is root 3 over 1. Tan of 3 pi over 4 is just 1. And tan, or 3 pi over 4, is going to be in my second quadrant, which is my sine quadrant, which is negative. So I'm adding negative 1 on top. And then I've got 1 minus tan pi over 3. I already know that's root 3 over 1. And then 3 pi over 4 is negative 1. So if I simplify that on top, I get root 3 minus 1. And then over 1 plus root 3. So my final one is sine of 25 pi over 12. And here, the very first thing that I'm going to do is use the property that sine repeats every 2 periods. So I'm going to write this as 24 pi over 12 plus pi over 12. So I know that this is 2 pi. So I know that I can just say that sine of 25 pi over 12 is equal to the sine of pi over 12. That one I can split up into the sine of 4 pi over 12 minus 3 pi over 12, which simplifies to pi over 3 minus pi over 4. And then I can use my sine identity to break up those angles. So I've got sine of x minus y, which simplifies to sine x cosine y, and then minus cosine x times sine of y, pi over 4 there. So these angles are all in my first quadrant, so they're all positive, and then I can evaluate using my special triangle. Sine of pi over 3 is root 3 over 2. Root 3 over 2. Cos pi over 4 is 1 over root 2. Cosine of pi over 3, double checking on my special triangle up here, is adjacent over hypotenuse, which is 1 over 2. And then sine of pi over 4 is also 1 over root 2. So finishing this simplification, I've got root 3 minus 1 over 2 root 2 as the exact value of sine 25 pi over 12. This video goes over how to prove the identities. So I'm going to start off by putting the left side and the right side, and I'm going to write down what I have on the left and on the right. Since the left side is in terms of tan and cotan, I'm going to try and change those into sine and cos. So cotan x would be cos x over sine x, and then tan y would be sine y over cos y. So I've got two terms. Now I'm going to use a common denominator, which is going to sort of mess up my t-chart here. So let's go over like this. So I'm going to have sine x cos y plus cos x sine y all over sine x cos y. So this is my denominator. That piece is the same. And if I go back and check my identities, this top part is actually sine x plus y all over sine x cos y, which means that I have proven the identity. The second one over here will start the same way. Start with my t-chart, left side and right side. On the left side, I've got sine x minus tan y cos x. And then on the right-hand side, I've got sine of x minus y over cos y. I'm actually going to start the same way by changing the left-hand side into terms of sine and cos. So here I've got sine x minus sine y over cos x times cos y. And instead of working on the right-hand side, I'm going to keep going on the left. I'm going to find a common denominator, which happens to be cos y. And now I've got sine x cos y minus sine y cos x all over cos y. Now my denominators are the same, and the top simplifies to the identity sine x minus y over cos y, which means that I've also proven that identity. This video goes over how to prove the two identities that are here, and now we're exploring some that have the addition identities. So in this first one, so I'm going to start off the same way. I'm going to divide it into the left side and the right side, and then I'm going to rewrite what we have on the left, and then I'm going to rewrite what we have on the right, and then I'm going to decide which one to work on. And I think on this one, the right-hand side is in terms of sine and cos, so I'm going to work on the left-hand side and try and get it in terms of sine and cos as well. So on the left side, I've got 1 plus cotan, which is cos x over sine x, and then I've got tan, which is sine x over cos x. Those are going to cancel out. That's not good.